All right, opening up our note packet, we're going to be looking at example number 8. We're going to be picking up where we left off yesterday, discussing the law of sines. Now in number 8, though, I want you to change a few things, okay? So, to solve triangle ABC with angle C, we're going to change him to 48 degrees. Little b is going to be 20. And little c is going to be 28 inches. I just like the way that those numbers work out in this scenario a little bit better. Okay, now solving triangle ABC, angle C is 48 degrees, little b is 20 inches, little c is 28 inches. Okay, now we know every single one of these, what is our absolute first step? Draw a triangle. Absolutely no question, we're going to draw that triangle. Everybody needs to have a picture of every single one of these.
We talked about that yesterday.
Okay, so triangle ABC, little a across from angle A, little b across from angle B, little c across from angle C. Okay, so the information that they give me, angle C is 48 degrees, little b is 20, little c is 28. Okay, now the first thing you need to ask yourself, the first thing you need to consider is what scenario am I given here? When I look at this situation, what scenario is it that I'm looking at? It is side-side angle. Okay, and that's the crappy one. Side-side angle is the crappy one. We have a side, and then an angle. Okay? So side-side angle is that crappy one. I'm even going to put a frowny face because that's the one that makes me think more. Now, what kind of angle do I have? Because that's really super important. Okay, my angle is an acute angle.
So that's a doubly crappy.
Yep, that's a double crappy one. Absolutely. When it's an acute angle, that's really our thinker. That's really our thinker. That means that I might have one triangle, I might have two triangles, or I might have no triangle. Now, the math we do is exactly the same. But the thinking that we have to do along the way really raises up our expectations a little bit. Okay, but we know that we set up law of sines. We use law of sines because I'm given an angle and the side across. Okay, anytime I have an angle and the side across, I know that I can use law of sines. Okay, so we're going to set up that law of sines. Sine of angle A, I don't know him, over little a, I don't know him either. I'm getting a little nervous, is equal to sine of angle B, I don't know that one either, over little b, which is 20, thank goodness, is equal to the sine of angle C, which is 48, over little c, which is 28. Now, do we feel pretty good about that? What makes us, when we look at this, think, oh, good, I can do this?
What's our most useful piece?
You bet. I have one full fraction that has both pieces. That's the most helpful piece right there. Now, I am looking for another fraction that is only missing one piece. Yeah, this fraction right here is only missing one piece. So I'm going to use those two fractions together to help me find angle B. So the sine of angle B over 20 is equal to the sine of 48 over 28. All right, looking good. What do we do from here? Karina, what did we do yesterday? Cross multiply, I love it. Okay, so we have 28 times the sine of that angle B is equal to 20 times the sine of 48. All right, anybody got a thought on what we're going to do to start getting angle B by itself? What do we do to start getting angle B by itself? Divide by 28. Looks good. Divide by 28. Okay, so my 28s are going to cancel, and the sine of angle B is equal to. All right, get out those machines, working hard. What is 20 times the sine of 48? Enter. Divide by 28. What did we get? 0.5308. All right, everybody double check Casey, make sure she's got it right there. Do we agree with that? Okay. Now, is that the angle B? No, that's the sine of the angle B. What do I use to find the angle? All right, I take the inverse sine on both sides. So that means the inverse sine helps me to find angle B. So what is the inverse sine of the 0.5308? 32? Okay. About 32 degrees. I can live with that. Okay? But now, okay, I got at least one triangle, right? But what do I have to do with that angle B, that 32 degrees? Is that the only angle B that I could have? Is 32 degrees the only angle B that I could have? No. What other way could I find a different angle B? 180 minus that. Okay, so another angle B is going to be 180 minus that 32, and angle B then would be how much? What? 148. I like it. Okay? So this is a big old OR. This means that how many triangles can I draw? 2. In this first triangle that I started right over here, I'm going to go in there and I'm going to put in, angle B is 32 degrees. But then I'm going to draw another triangle that looks exactly like that. I'm going to draw another triangle that looks exactly like that, and I still know angle C is 48 degrees. I still know little b is 20 degrees. I still know little c is 28. But in this triangle, what do I know? In this second triangle that I draw, what do I know? Angle B here is going to be 148 degrees. Okay, Quinn is thinking. He's thinking, there's something wrong here. What is wrong? 148 and 48. What do you notice about that? Yeah, it's over 180. Can I have a triangle that has an angle of 148 and another angle of 48? No. So can I have two triangles? No. I'm going to throw that one away. I tried to make my second triangle, and I couldn't find, because an angle of 148 doesn't work as a second triangle. Now, am I done over here? What did my instructions tell me? Solve the triangle. What does it mean when we are solving the triangle? Find every side and every angle. Okay, so anybody got a thought in this picture right here? What's the next thing I could probably find? Oh yeah, angle A. How am I going to find that angle A? How am I going to find that angle A? From 180, you bet. 180, take away the 32, take away the 48. What do we get for 180, take away 32, take away 48? 100. All right, so angle A is 100. All right, now we know we're going back to that law of sines every time. So the sine of angle A, which is now 100, over little a, I don't know him, is equal to the sine of angle B. Oh yeah, that's right, he's 32, over little b, which is 20, is equal to the sine of 48 over little c, which is 28. And I remember that this fraction is the most helpful fraction that we had because it had two pieces right off the start. Now, in this case, that fraction is going to help me to find what?
Good job, Tyler.
What?
Say it.
Little a, absolutely. The sine of 48 over 28 is going to be equal to that sine of 100 over little a. I'm missing that piece of little a. All right, Zeno, what do I do to find that little a? Cross multiply. Very nice. So I put my x there in the middle, cross multiply. 28 times the sine of 100 is equal to little a times the sine of 48. Looking good. Karina, where do we go from here? Divide each side by the sine of 48. Okay, so that's going to cancel. So little a is about equal to how much? All right, calculators are running. We're taking 28 times the sine of 100, hitting enter, and then dividing it by the sine of 48. What do we get? About 37.1. Very nice. About 37.1. Are we okay with that? Feel pretty good about that?
Do we have to do the inverse?
Okay, and that's a great question, Zena. Did I find, is little a an angle? No. When I use the inverse sign when I'm finding the angles, right? Yep, I use the inverse sign when I'm finding the angles. Little a is a side, so I never have to use the inverse. It's a great question. Anything else? All right, you know what? We're going to go to the back page. We're going to do one more problem together. Just one more problem together, and we're going to see how we're doing.
I know some of you want to use your iPod, iPhone, whatever fancy gadget you have, but a lot of them do not have the inverse of sine. You need to use a little calculator.
Your iPod actually will have, most of them have the inverse sign if you take it and you flip it horizontally.
Even some don't.
Okay.
The couple that well, you have 2 apps that you on yours. So just,
The regular, I think it's the regular calculator on the iPod. If you flip it horizontal, it becomes a scientific calculator, and then it should have inverse sign.
Yeah.
But,
maybe a couple,
yep,
a couple still don't.
yep, and it's possible that, your phones and stuff probably aren't going to have it on there. And obviously on any tests or quizzes, phones and iPods are out the door. Yep, you got to use either one of our calculators or a regular old jalopy. There's too many things that can be, not that we don't trust each and every one of you, but there are too many things that can be stored on those devices. All right, so let's try another one. Let's take a look at number 9. Okay, let's take a look at number 9. And I'm actually going to rewrite the information so we have plenty of room here. In number 9, we're going to solve triangle ABC with angle C being 36 degrees, little b is 11 inches, and little c is 8 inches. All right. Okay, first step. You bet. Draw that picture. It's not an option, it's an expectation. So we have triangle ABC. Little a is across from angle A. Little b is across from angle B. Little c is across from angle C. All right, then I go back and I figure out what information they gave me. Okay, so angle C is 36 degrees. Little b is 11 inches. Little c is 8 inches. All right, first thing you got to ask yourself every single time is, what situation am I in? What situation is this? Side, side, angle, and then you go, oh darn. Yep, we got a side, and then an angle. Now, after I know that it's side, side, angle, what's the next question that I need to be asking myself? What kind of angle is it? Okay, we got an angle that's 36. What kind of angle is it? All right, we have an acute angle. Now, is that a good thing or a bad thing? That's bad.
Double bad.
Yep, that's a double bad. Because when it's acute, that means we might have one triangle, we might have 2 triangles, or we might have no triangle. This is the thinker. This is the thinker. All right. Kendall, can you help me out here? Can you help me set up the law of sines?
Sine of big A equal to the sine of big
Perfect. Boy, Fabiola, how you feeling about that? Does it look good? Kendall did a nice job? Oh yeah. Which piece is the most useful for you? Which one's the helpful one? Beautiful. This fraction right here, sine of 36 over 8, it's got both pieces. Now, Casey, which piece is it that I'm going to be finding first? The sine of b. Okay, because the angle b, this fraction's only missing one piece. So sine of angle b over 11 is equal to the sine of 36 over 8. All right, Alex, tell me what we're doing here.
Cross multiply.
Yep, tell me what I'm writing.
11 times sine of 36 and sine of b times 8.
All right. So what am I doing to get angle B?
You divide by 8.
Good, we're going to divide both sides by 8. Okay, so that gives me the sine of B then on this side when my 8's cancel. All right, what do we have there? 11 times the sine of 36, enter, divide by 8. What do we got there? 11 times the sine of 36 divided by 8. What'd you get, Ashley? 0.8082. All right, so is angle B 0.8082, Hunter? No. The sine of the angle is 0.8082. How do I find the angle? Inverse sine. Inverse sine on both sides helps me to find that angle. So, what do we get for angle B when we do inverse sine of 0.8082? Yep, if we round it, it's 54 degrees. Okay, now, is that the only angle B we can have? No. No, we have to find another angle B because it's 0, 1, or 2 triangles. So how do I find the other angle B? What?
80.
Yep. The other angle B is going to be 180. Subtract the 54, which is 126. Okay, now I got to draw a whole new picture for that one. I've got to draw a whole new picture, a whole new triangle ABC. Little a across from angle A, little b across from angle B, little c across from angle C. And I know we knew that C was 36. We knew that little b is 11 inches. We knew that little c is 8 inches. But in this picture, what do I know? Angle B is 126. Is that okay? Why is it cool?
Because it's less.
Yeah, it's not 180. The two of them together don't get me to 180. Over here, angle B is how much? 54. Is that okay? Yeah, they're definitely under 180. Okay, now guess what? This is like having two problems. This is like having two problems at this point. I go this triangle its own problem, and I go with this triangle its own problem. So let's start, first of all, on this side. Now, on this side, that means that I'm going to, what is the first thing in this triangle that I'm looking for? What is the next thing that I could find in this triangle? Angle A. Beautiful. How do I find that angle A?
54 plus 36, subtract about.
You bet. 180, take away the 54, take away the 36. How much do I get for that angle A? How much do I get for that angle A? 90. Well, that's strange. 90. Boy, the way I drew it, it sure doesn't look like 90, does it? Now, I can set up law of sines, right? So if I set up that law of sines now, we have sine of angle A, but I know him, he's 90, over little a, is equal to the sine of angle B, but I know angle B, which is 54, over little b, which is 11, is equal to the sine of 36 over 8. And I go back to that first fraction, that most helpful fraction, because that fraction's going to help me find what? It's going to help me find little a. The sine of 90 over little a is equal to the sine of 36 over 8. All right, tell me what to do, Quinn.
Well, cross multiply.
Yep. Good. 8 times the sine of 90 is equal to? Little a times sine of 36. Beautiful. What am I going to do to get little a by itself there, Alex? Divide both sides by the sine of 36, and then it becomes a calculator game. All right, somebody got that little a. What do you get for 8 times the sine of 90, then divided by the sine of 36? Somebody have that? 13.6. All right, now am I done? I mean, because that means that little a over here is 13.6. Am I done with this triangle? Yeah, I got all the sides and all the angles for this triangle, but now I need to go back over to this one. And I'm treating him like his own problem. If I look at the information in this triangle, what's the next thing I would want to find over here in this triangle? Angle A. All right, so angle A, what are we doing? 180, take away 126, take away 36. What do we get for angle A in that one? 18. Small little critter. So we got angle A of 18. And we're going to go back and set up law of sines. So sine of angle A, which is 18, over little a, I don't know, is equal to the sine of angle B, which is 126, over little b, which is 11, is equal to the sine of angle C, 36, over little c, which is 8. And once again, I'm excited. I see that full fraction there, because that full fraction is going to help me find what, Tyler? Little a.
Could you have used the middle one this time if you wanted to?
I could, but my problem is this. When we got 126 for my angle, and when we got 54, did it come out exactly as 54? We rounded, right? So this one was never rounded, so we should really always go back to our original fraction. The original's always the best because we know that we never rounded anything from what they gave us. All right, so the sine of 18 over little a is equal to the sine of 36 over 8. All right, let's see here. Taylor, can you tell me what to write here? Beautiful. 8 times the sine of 18 is equal to a times the sine of 36. Fantastic. Tyler, what am I going to do from here? Divide both sides by the sine of 36. I love it. So what do we get for little a in this case? So about 4.2. So that means that little a here is about 4.2. Am I done with that triangle?
Yes.
Because I know every side and every angle.
It's 4.0.
I got 4.205.
Oh, I got 4.015.
Okay, try that again. 8 times the sine of 18.
You only want to round to
Hit enter. And then divide by the sine of 36. Must have just hit a key wrong somewhere. It happens all the time to all of us. Questions with that? We feel pretty good about this?
Yeah, but once put into the whole
What?
the whole
If we round to the nearest tenth, we're okay on the sides. Yep. Anything else?
I said whole.
Okay.